Okay, today we're going to review for our Chapter 8A test on rational functions. We're focusing today on, to start out here, on variation problems. It says to write a function that models the variation. X is -2 when y is 6, and it tells us that y varies inversely as x. So we start out with that basic structure for inverse variation, y equals k divided by x, and we can plug our values in. We can put a -2 in for x, we can put a 6 in for y, and we can use that then to solve for k. Multiplying the -2 to the other side, we get -12 equals k. Our last step then is to actually write the function by plugging that value in for k. So we get y equals -12 divided by x. Okay, second question. We have x equals 6 and y equals 9 when z equals 12. Our variation statement says z varies inversely with y. So we're going to start out z varies. Inversely with y means y is on the bottom. And directly with the square of x means we're going to plug in an x squared in a direct relationship. So it's on top. So we have our basic structure. Now we can dump our variables in, our values for our variables. We know that z is 12, x is 6, and remember you're squaring that, and then y is 9. All right, multiplying, we end up with 12 equals 36k divided by 9. 36 divided by 9 would be 4, so we have 12 equals 4k, and then dividing we end up with k equaling a 3. So dumping that into our equation, our final answer, our function is z equals 3x squared divided by y. All right, the next type of question asked us to look at a table of values and determine the type of relation. Is it direct variation, inverse variation, or neither? And then once we figure it out, they do want us to come up with an equation that would model it. All right, so to review, if it is direct, we know that y equals k times x. So we would have to divide y by x and get a constant every single time for it to be direct variation. So let's try that. If it doesn't work, we can try the inverse option. So let's take our y values. 6 divided by -2 would get us -3. If we do -3 divided by 4, we're not getting -3. So this is not a direct variation problem. It's not working. Okay? So let's go and try inverse variation. If it is inverse, y equals k divided by x, and to solve for k, we would multiply the x and y together. So x times y has to give us a constant. Well, if we multiply these together, we get -12. If we multiply these together, we get -12. Multiplying these, we get -12. So our constant here is -12. So the type of variation we would say is inverse. And then the equation we would say would be y equals -12 divided by x. So we're finding that k value and then dumping it back into our structure. All right, question 4, again, if it is direct variation, then our y divided by x's should be a constant. So let's try that. Take y divided by x, do we get a constant? 8 divided by 2 would be 4. -20 divided by -5 is 4. And 1 divided by 0.25, or 1/4, is also 4. So we know that k has to be 4, and it did fit this option, which was direct. So we have a direct variation problem, and the equation would be y equals 4x. All right, question 5. Using variation, describe how the variables in the given equation are related. Remember, we never talk about k because it is the constant of variation, so we don't have to describe it. We are simply describing the variable parts. And k is a constant, so it does not have to be referenced. Our equation says x equals, so we start out x varies. That takes care of the x, the equal sign, and the k value. So it varies, since the y is in the numerator, it varies directly with y. And because the W and the Z are both in the denominator, we could say and inversely with the product of W and Z. All right, so W and Z are getting multiplied, but they're both in the denominator, so it's an inverse variation. All right, shifting now to some of our graphing. It says to write an equation for the translation of y equals 4 divided by x that has the given asymptotes. So remember, if we just look at y equals 4 divided by x, we have a basic picture with branches in first quadrant and third quadrant, okay? And the asymptotes would be right here on the axes. But we want to shift our vertical asymptote to being x equals 2. So we want to move it over here, which means we are shifting right 2. And then we want our horizontal asymptote to be down here at -3, which means we had to shift down 3. So we want to write an equation that has those two translations in it. We know we start with the generic y equals 4 divided by x. To move right 2, we would need to have a -2 in the denominator with our x. And to move down 3, we would have to have a -3 on the outside as our k value. Okay, so this was h, this was k. Okay, question 7 through 9. It says identify any holes, horizontal or vertical asymptotes. So we're not actually graphing these, we are simply looking for information about them. So let's start out looking at the degree. Before we even do any kind of factoring, degree is easiest to see in unfactored form. So looking at our example here, number 7, we have a top degree of 2, our highest power is a 2. Our bottom degree, even though we don't see it, is a 1. So if the top is more than the bottom, then we don't have a horizontal asymptote. So we're going to say none for that. All right, now to find holes in vertical asymptotes, we actually have to get it into factored form. So let's factor the numerator. We can factor out a 3 and an x. It would leave me an x plus 3. And now I look for those points of discontinuity, what makes the denominator equal to 0. And in this case, when x equals a -3, we would have a problem. So what we have to do is decide, is that a hole or a vertical asymptote? Since we have a matching factor in the numerator and the denominator, it means we can remove it. If it is removable, then it is a hole. So we would say we have a hole when x is -3. And we didn't have any other points of discontinuity, so we would say there are no vertical asymptotes as well. All right, to find the actual location of that hole, we look at the simplified version of this. If we drop out these x plus 3 common factors, we really are just looking at the equation y equals 3x. So when we put a -3 in there for x, our y coordinate would be -9. So the whole location would be -3, -9. All right, moving to question 8. Again, let's analyze our degrees first. Our top degree is 1, our bottom degree is 1. When the degrees are same over same, so the degrees match, we move to the leading coefficients. All right, so our leading coefficients in this case, we have a 3 in the numerator, and we have a 1 in the denominator. So our horizontal asymptote would be at y equals 3. 3 divided by 1. Looking at the denominator, our points of discontinuity, the things that make us have an issue in the denominator, would be when x equals -2, because x plus 2 can't be 0. We don't want x to be a -2. So -2 is a point of discontinuity. Since we cannot remove it, there's no x plus 2 in the numerator, that means it's a vertical asymptote. So x equals -2 is our vertical asymptote. We have no other points of discontinuity, So we would say there are no holes. All right, question 9. We have y equals x minus 4 divided by x plus 5 and 4 minus x. Now, notice that we have an x minus 4 in the numerator, and we have a 4 minus x in the denominator. Those are just opposites. So we can reduce them out, but it leaves a negative 1 left. In other words, let's think of this as saying y equals x minus 4 on top, and let's factor a negative 1 out so that it turns that one into an x minus 4 instead of a 4 minus x. And then we also have an x plus 5 factor in the denominator. All right. Simplifying this, we can get rid of the x minus 4. So this is going to simplify down to just 1 over negative times x plus 5. Or we could move that negative to the top, negative 1 over x plus 5. Same thing. All right, looking at the degree. Since it was already factored, let's go ahead and look at the simplified version. The degree of our simplified version is that we have no x's on top, so degree 0, and on the bottom we have degree 1. So we have less for a degree on top than we do have on the bottom, which means we have a horizontal asymptote at 0, y equals 0. If you were going to look at it before we simplified it, you'd actually want to FOIL out that denominator so that you can see that it has a degree of 2 and the top has a degree of 1. Still less over more. All right, looking at the denominator, we have 2 points of discontinuity, 2 things that make the denominator 0, a negative 5 and a positive 4. Okay? Since the x minus 4 piece was able to be reduced out, that means it is removable, which means it is a whole. Okay, so we have a whole when x is 4. Since we were not able to remove the x plus 5 factor, then x being negative 5 is going to be a vertical asymptote. And then once again, to figure out the y-coordinate of our whole, we have to go to our simplified version. So we have y equals negative 1 over x plus 5. We're going to dump in that 4 for x, and we end up with negative 1/9 for the y-coordinate of our whole. All right, the last couple we're going to work through the whole process, and we're going to do the graphing as well. Okay, so question 10, again, it's already given to us in factored form, so we can simplify out those x plus 1's, and we really just get 1 divided by x minus 3. Be very careful. It's important that that x minus 3 that's left over is shown in the denominator. When we reduce these out, we really leave just a 1 in its spot. So our simplified version would be 1 over x minus 3. Since we have a whole where we can remove that point of discontinuity, let's go back here. Our points of discontinuity, x being negative 1 and x being 3. Those are the 2 things that create zeros in the denominator. Since the x plus 1 can be reduced out, it is a whole. So negative 1 is going to be the x-coordinate of my whole. And the x equals 3, since I can't remove it, is a vertical asymptote. Looking at the horizontal asymptote, again, my top degree would be 0 since I don't have any x's. My bottom degree is 1. So I have less on top. It's a less over more situation, which means we have one at y equals 0. All right, let's figure out the location of our whole. Let's plug a negative 1 in for our x value. All right, if we put a negative 1 in here, we end up with negative 1/4. All right, so let's plot that information. We have a vertical asymptote at 3. We have a horizontal asymptote right at 0. And we know that there is a whole when at the point negative 1, negative 1/4. So we have one just underneath the x-axis right there. All right, now, once we've finished graphing that, we want to find any x and y intercepts. So let's go ahead and put a 0 in for x so we can find our y-intercept, and put a 0 in for y so we can find our x-intercept. All right, looking at our simplified version here, if we put a 0 in for x, we end up with 1 divided by -3, or -1/3. So that is going to be the y-intercept. I'm crossing the y-axis here at -1/3. If we put a 0 in for y, we get 0 equals 1 divided by x minus 3. When we multiply the x minus 3 to the other side, we end up with 0 equaling 1, which can't happen, so we would say there's none. There are no places where we touch the x-axis, which makes sense. We have a horizontal asymptote on the x-axis, so it's quite possible that we would not be crossing that. All right. We need to find a few more points, so we can grab the calculator if you want, or we can just pick a couple x values on either side of that vertical asymptote. Since the vertical asymptote was at 3, let's look at maybe a 4 and a 5. If we put a 4 into our function, we get 4 minus 3 on the bottom, which is 1. 1 divided by 1 is just 1. We put a 5 in there. 5 minus 3 is 2. 1 divided by 2 would be a half. So we have the point 4, 1 and 5, 1/2. So sketching the best graph we can, it looks like we are coming down along this vertical asymptote and hitting those 2 points. Trying to hit those 2 points. And just approach those asymptotes. All right, on the bottom, we are coming up along this vertical asymptote, hitting that y-intercept. We have to kind of jump over that little hole, and then we extend on past it, approaching the asymptote from underneath. All right, our last example. Now notice on this one, it's not in the same format that the last 4 examples have been in. It is not where we have a polynomial divided by another polynomial. Okay? This is in transformation format. So we can look at it and just say, I'm going to graph the parent function and then just shift it. All right? So we look at y equals 1 over x is my parent function. The minus 2 down with the x means I am going to move right 2, and I'm going to shift up 3. So let's graph our parent function, y equals 1 divided by x. Let's just pick a couple values, -2, -1. We can't put a 0 in because that's undefined. And let's put in a +1 and a +2. So 1 divided by -2 would be -1/2. 1 divided by -1 is -1. 1 divided by 1 is 1. And 1 divided by 2 is 1/2. All right, so we'll plot those points. -2, -1/2. -1, -1. 1, 1. And 2, 1/2. Okay, so we have those 2 branches, one in quadrant 1 and one in quadrant 3. We are shifting this right 2 and up 3. So instead of our vertical asymptote being right on the axes, we are going to move that. We're going to move it right 2. So my new vertical asymptote is going to be here. And my new horizontal asymptote needs to move up 3. So it's right there. And then we're going to just take our points and shift them. All right. So we had a point at 2, 1/2. If I shift it right 2, I'm at 4, and up 3 puts me at 3.5. I had a point at 1, 1. Shifting it right 2 puts me at 3, and up 3 puts me at 3, 4. So we have a branch coming down here. Shifting the 2 in quadrant 1, I had the point -1, -1, right 2, and up 3 puts me at 1, 2. The point -2, -1/2, right 2, up 3 puts me at 0 and 2.5. So we have a branch right in there. Okay? Now, for a basic transformation like that, there are no holes. We said the vertical asymptote moved right 2, so it shifted to x equaling a 2. And our horizontal asymptote moved up 3, so it shifted to y equals 3. Our domain is all reals, except x cannot equal where the vertical asymptote is. So x cannot equal a 2. And my range is all reals, except y can't equal where the horizontal asymptote is. So y cannot equal a 3. All right. You are going to be working on Supplemental Practice Worksheet 8A, and let me know if you have any questions.